Welcome friends. In this session, I am giving you a brief introduction to the fundamentals of computers. The word computer comes from the word compute, which means to calculate. Generally, a computer is considered to be a calculating device that can perform arithmetic operations at high speed. In fact, the original objective for inventing a computer was to create a fast calculating machine. However, more than 80% of work done by today's computers is of non-mathematical or non-numerical in nature. So, more accurately, we can define a computer as a device that operates upon data. Data comes in various types and sizes depending upon the type of computer application. A computer can store, process, and retrieve data as and when required. Computer science is the study of computers and their architecture, languages, and applications in all aspects, as well as the mathematical structures that relate to computers and computation. Thus, it laid a foundation for computer design, computer programming, information processing, algorithmic solution of problems, etc. The characteristics of computers. The power and usefulness of computers are mainly due to the following characteristics. Automatic. Once started on a job, computers carry out the job until it is finished. But we need to instruct a computer using coded instructions that specify exactly how it will do a particular job. Accuracy. Accuracy of a computer is consistently high, and the degree of its accuracy depends upon its design. A computer performs every calculation with the same accuracy. Diligence. Unlike human beings, a computer is free from monotony, tiredness, and lack of concentration. It can continuously work for hours without creating any error and without grumbling. If 10 million calculations have to be performed, a computer will perform the last one with exactly the same accuracy and speed as the first one. Power of remembering. A computer can store and recall any amount of information because of its secondary storage capability. It can retain a piece of information as long as a user desires, and the user can recall the information whenever required. A computer forgets or loses certain information only when a user asks it to do so. So, it is entirely up to the user to make a computer retain or forget some information. Speed. A computer is a fast device. Computers are capable of performing several billion arithmetic operations per second. Versatility. It is one of the most wonderful things about a computer. A computer is capable of performing almost any task if the task can be reduced to a finite series of steps. Evolution of computers. The computer truly is one of the most incredible inventions in history. The electronic computer has been around for over a half century, but its ancestors have been around for 2000 years. From the first wooden abacus to the latest high-speed microprocessor, the computer has changed a lot, both internally and externally. The main goal of computer manufacturers was to make the computer as affordable as possible while increasing speed, reliability, and capacity. Nearly every computer manufacturer accomplished this, and computers popped up everywhere. Computers were in businesses, keeping track of inventories. Computers were in colleges, aiding students in research. Computers were in laboratories, making complex calculations at high speeds for scientists and physicists. The computers had made its mark everywhere in society and built up a huge industry. Blaise Pascal invented the first mechanical adding machine in 1642. In the year 1671, B.J. Wilhelm von Leibniz of Germany invented the first calculator for multiplication. Keyboard machines originated in the US around 1880. Around the same period, Hermann Hollerith came up with the concept of punched cards that were extensively used as input medium in computers even in late 1970s. Charles Babbage, a 19th century professor at Cambridge University, is considered to be the father of modern computers. Babbage designed a difference engine in the year 1822 that could produce reliable mathematical and statistical tables. Built into his machine were operations that included everything a modern general-purpose computer would need. It was programmed by and stored data on cards with holes punched in them, appropriately called punch cards. In 1842, he came out with his new idea of a completely automatic analytical engine for performing basic arithmetic functions for any mathematical problems. Unfortunately, he was unable to produce a working model for this machine. Some of the well-known early computers are the abacus. It is simply a wooden rack of holding parallel wires on which beads are strung. When these beads are moved along the wire according to programming rules that the user must memorize, all ordinary arithmetic operations can be performed. The Mark I computer, 1937 to 44. It is also known as Automatic Sequence Controlled Calculator, and it was the first fully automatic calculating machine designed by Howard A. Aiken. It was an electromechanical device based on the techniques already developed for punched card machines, which can handle 23-digit numbers. Though it was very complex in design and huge in size, it was extremely reliable. It was capable of performing 4 basic arithmetic operations: addition, subtraction, multiplication, division, and had special built-in programs to handle logarithms and trigonometric functions. The Atanasoff-Berry computer from 1939 to 42. Dr. John Atanasoff developed an electronic machine to solve certain mathematical equations. The machine was called Atanasoff-Berry computer, or ABC. It used 45 vacuum tubes for internal logic and capacitors for storage. The ENIAC from the period 1943 to 46. The Electronic Numerical Integrator and Calculator, ENIAC, was the first of all electronic computers. In 1942, John P. Eckert, John W. Mushley, and their associates at the University of Pennsylvania developed ENIAC for military needs. It could add 2 numbers in 200 microseconds and multiply them in 2000 microseconds. The EDVAC, 1947 to 49. The major drawback of ENIAC was that its programs were wired on boards that made it difficult to change the programs. The Electronic Discrete Variable Automatic Computer, or the EDVAC, used the stored program concept in its design. Dr. John von Neumann introduced the idea of storing both instructions and data in binary form, that is, stored program, instead of decimal numbers or human readable words. This feature considerably influenced the development of modern digital computer because of the ease with which different programs can be loaded and executed on the same computer. The EDSAC, 1947 to 49. Almost simultaneously with EDVAC, the Britishers developed the Electronic Delay Storage Automatic Calculator, or the EDSAC. A group of scientists headed by Professor Maurice Wicks at the Cambridge University Mathematical Laboratory developed this machine. In this machine, addition operation took 1500 microseconds and multiplication operation took 4000 microseconds. The UNIVAC I, 1951. Universal Automatic Computer 1 was the first commercial computer produced in the United States. It was designed principally by J. Presper Eckert and John Mushley, the inventors of ENIAC. Design work was begun by their company, Eckert-Mushley Computer Corporation. UNIVAC I used 5,200 vacuum tubes, weighed 29,000 pounds, consumed 125 kilowatt, and could perform about 1,905 operations per second, running on a 2.25 MHz clock. In the 1970s, programmable mini computers supplied with software packages. The size reduction trend continued with the introduction of personal computers, which are programmable machines small enough and inexpensive enough to be purchased and used by individuals. The first computer of this type was called the Altair 8800. Its programming involved pushing buttons and flipping switches on the front of the box. It didn't include a monitor or keyboard, and its applications were very limited. Computer generations. Generation in computer terminology is a step in technology. It provides a framework for the growth of computer industry. The custom of referring to computer era in terms of generations came into wide use only after 1964. Although there is a certain amount of overlap between different generations, the approximate period shown against each are normally accepted. First generation from 1942 to 1955, ENIAC, EDVAC, EDSAC, UNIVAC I, IBM 701. Second generation from 1955 to 1964, Honeywell 400, IBM 7030, CDC 1604, UNIVAC LAC. Third generation from the period 1964 to 1975, IBM 360 or 370, PDP-8, PDP-11, CDC 6600. 4th generation 1975 to 1989, IBM PC and its clones, Apple II, TRS-80, VAX 9000, Cray 1, Cray 2, Cray XMP. 5th generation from 1989 to present, IBM notebooks, Pentium PCs, Sun workstations, IBM SP2, SGI Origin 2000, Param 10000. When we consider the advancements in hardware, the key characteristics of each generation can be summarized as follows. Generation and period and key hardware technologies. First, 1942 to 55, vacuum tubes, electromagnetic relay memory, punched cards, secondary storage. Second, 1955 to 64, transistors, magnetic core memory, magnetic tapes and disk secondary storage. Third, from 1964 to 75, ICs with SSI and MSI technologies, larger magnetic core memory, larger capacity magnetic disk and tapes, secondary storage mini computers. Fourth, 1975 to 89, ICs with VLSI technology, microprocessors, semiconductor memory, larger capacity hard disk as inbuilt secondary storage, magnetic tapes and floppy disk as portable storage media, personal computers, spread of high-speed computer network. Fifth, from 1989 to present period, ICs with VLSI technology, larger capacity main memory, larger capacity hard disk, optical disk as portable read-only storage media, notebook computers, powerful desktop PCs and workstations, very powerful mainframes and the internet. Successive generations have their size decreased, but the capabilities, uses and reliability increased. They became more and more user-friendly, efficient and are easier to produce commercially. When we take into account the software technologies and the applications of each generation computers, it can be categorized as generation and software technologies and applications. First, 1942 to 55, machine and assembly language, stored program concept used for calculations. Second, from 55 to 64, batch operating system, high-level programming languages, scientific and commercial applications. Third, 1964 to 1975, time-sharing operating system, standardization of high-level programming languages, unbundling of software from hardware. Fourth, from 1975 to 1989, operating systems for PCs, GUI, multiple windows on a single terminal screen, Unix operating system, C programming language, PC-based applications, network-based applications. Fifth, from the period 1989 to present, World Wide Web, multimedia applications, internet-based applications. Number systems. A computer stores data internally in a format that is not easily readable by human beings. A computer stores characters, numbers and all special characters in coded form. These codes are based on the number system. Generally, number systems are of two types, non-positional and positional. In early days, human beings used fingers, stones, pebbles, etc. to count. This method uses non-positional number system, since each symbol represents the same value regardless of its position in a number. In positional number system, there are only a limited number of symbols called digits, but these digits represent different values depending on the position they occupy in a number. We use decimal number systems in our day-to-day life. It uses 10 symbols or digits. They are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Thus, its base is equal to 10. In a decimal number system, successive positions from right to left to the decimal points represent units, tens, hundreds, etc., which is a specific power of base 10. The number 8745 to the base 10 can be written as 8 into 10 cube plus 7 into 10 square plus 4 into 10 raised to 1 plus 5 into 10 raised to 0, which is equal to 8000 plus 700 plus 40 plus 5, which is equal to 8745. From the following example, we can see that the same digit signifies different values depending on the position of that digit in the number. In 6573 to the base 10, the digit 3 signifies 3 into 10 raised to 0, which is equal to 3. In 6357 to the base 10, the digit 3 signifies 3 into 10 square, which is equal to 300. The number systems relevant to computers are binary number system. It's like decimal number system, but the base is 2 because it uses only 2 digits 0 and 1. Each position in a binary number represents a power of the base 2. Thus, the rightmost position is units, that is 2 raised to 0. The second from right is 2s, 2 raised to 1, etc. The decimal equivalent of a binary number 11101 to the base 2 is 1 into 2 raised to 4 plus 1 into 2 raised to 3 plus 1 into 2 raised to 2 plus 0 into 2 raised to 1 plus 1 into 2 raised to 0, which is equal to 16 plus 8 plus 4 plus 0 plus 1, which is equal to 29. Octal number system. In octal number system, the base is 8. So, there are 8 symbols or digits 0, 1, 2, 3, 4, 5, 6 and 7. Each position represents a power of the base 8. Thus, the decimal equivalent of octal number 1024 to the base 8 is 1 into 8 raised to 3 plus 0 into 8 raised to 2 plus 2 into 8 raised to 1 plus 4 into 8 raised to 0 equal to 512 plus 0 plus 16 plus 4, which is equal to 532. Hexadecimal system. Here the base is 16. Hence, there are 16 symbols or digits. The first 10 digits are same as that of decimal number system. They are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The other 6 digits are the A, B, C, D, E and F. Each position represents a power of the base 16. The decimal equivalent of the hexadecimal number 45F to the base 16 can be written as 4 into 16 square plus 5 into 16 to the power 1 plus F into 16 to the power 0, which is equal to 4 into 256 plus 5 into 16 plus 15 into 1, which is equal to 1024 plus 80 plus 15, which is equal to 1119. Algorithms. In order to solve a problem, we need to know the steps to solve the problem and the sequence in which these steps to be applied. As we said earlier, for the computer to solve a particular problem, it should be instructed the steps to be followed to reach a solution. To ensure that the instructions of a program are suitable for the problem and are in the correct sequence, it should be planned before writing it. Planning involves defining the logic. Algorithm means logic. It can be defined as a sequence of precise and unambiguous instructions which, when executed in the specified sequence, produces the desired result. Here, each instruction should be executed in a finite time. There are different methods to represent an algorithm. The important ones are as programs, represented using programming language. Every program is an algorithm, but every algorithm is not a program. As flowcharts, pictorial representation of an algorithm. It is used for visually organizing a sequence of steps to solve a particular problem. As pseudocodes, instructions written in ordinary natural languages like English. Computer languages. Just as we have various languages to communicate with one another and each language has its own vocabulary and grammatical rules, we have different languages to convey instructions to the computer. Every computer language has its own rules called syntax and vocabulary called keywords. There are 3 types of programming languages: machine level language, assembly level language and high level language. The language which a computer can understand is called a machine level language, that is in the binary form. The program written in machine level language is totally dependent on the individual machine. As machine language is the language of the CPU, programs written in this language are executed very fast. Writing programs in this language is very time consuming and error prone. Because of these limitations, programs are rarely written in machine level languages nowadays. Assembly language is one level above the machine level language. It uses certain predefined symbolic codes called mnemonics instead of binary codes. Assembly language closely resembles machine language and both are considered low level languages. Since a computer cannot understand assembly language, a translator called assembler converts the assembly codes to machine understandable format. Some of the limitations of machine level language have been overcome in assembly level language, but the coding and debugging continue to remain difficult as it is written using some special character. To solve this problem, high-level languages came into existence. Most of the programs in high-level languages are written in general English, hence it is easy to learn, code and debug. High-level languages are designed for providing better programming efficiency, but special translators are needed to convert the code into the machine understandable format. There are two types of translators, namely interpreters and compilers. The interpreter is a special type of program that translates the program written in a high-level language into machine language at the time of executing that program line by line and finds if any syntax error in the code. Therefore, no object code is saved for future use because the translation and execution processes alternate. Most of the interpreted languages are slow in execution. Example, BASIC, Perl, etc. The compilers are special type of programs that checks for syntax errors. If an error is found, the compiler points out the error and gives a message to the programmer. Before a program is executed, the code is compiled and the entire high-level language program is converted into machine understandable format called object program. The compiled form is directly given for execution, no interpretation, as it is already in the machine language format. Thus, the compiler-based languages are faster. Example, C, C++, etc. The basic principles of computer science. Even though the size, shape, performance, reliability and cost of computers have been changing over the years, the basic concept of stored program has not changed. For converting the raw data into information and presenting it to a user, a computer performs 5 basic operations. 1. Input, receiving data into a computer system. 2. Store, saving data and instructions for processing. 3. Process, performing arithmetic and logical operations. 4. Output, producing results for a user, either soft copy or hard copy. 5. Control, control the way and sequence in which these operations are performed.
Please try to answer the following questions. Define computer. What will be the decimal equivalent of 24.1875 to the base 16? Convert the binary number 100011 to the base 2 to decimal. Write a short note on compilers and interpreters. What is the role of assembler? Explain the evolution of computers. What are the different programming languages? What are the different characteristics of a computer? Books for your reference. J. Glenn Brookshire, Computer Science, an Overview, 10th edition, Edison Wesley. Pradeep K. Sinha and Preeti Sinha, Computer Fundamentals, 4th edition, BPB Publications.
Hope you enjoyed this session. See you next time. Bye. Take care.